Morning, everybody. Alrighty. How are we all doing today? Hey, it's 10 o'clock. Look at that. Right on time. Right. Let's end the music. Haha. Alright. Welcome back from your most difficult midterm you probably had this semester. Um, just kidding. Hopefully it wasn't too bad. Alright, so I will say I was very impressed with how everybody did on their term project presentations at the midway point. I'm going to get caught up with grading, so you will all get your grades fairly shortly, I would hope. Um, yeah, just keep an eye on Blackboard, I suppose. And I'm assuming that most of you probably saw that I sent out an email about the feedback, so I know that, actually I think for this section I didn't have a problem, but I didn't get to putting up the PDFs until last night of everybody's presentation. My goal was to do that on Saturday, and I didn't get to it until Sunday night because of real life. So rather than punish you for me getting something up late, I just pushed the deadline back for your, um, your term project feedback. So you technically have until Tuesday night now for something that you probably could have done by Friday. Um, and then later this week, I'll put up the next homework assignment as well. It'll probably be design pattern related, oddly enough, because we're talking about design patterns. And what else is going on? November started, so we basically have a month and a couple of weeks until we get to our final exam time slot. So basically consider that you have probably 5 weeks to finish off all the super nifty things that you plan to do for your term projects. Hopefully your Gantt charts or your burn up or your burn down charts, depending on what you implemented, is helpful for structuring that. Um, Now might be the time that you're thinking of adding in extra features, adding in all of this extra stuff. um, Let me finish my point first and then I'll get to your point. Don't let scope creep or feature creep take over your project. Get something that is functioning and then add in the cool stuff. So that's just my one warning, because right now your demos all look really cool. Some of them I could see where there's a desire to go harder and deeper into the project, and just realize you only have not that much time left in reality to get all those things done on top of your other classes. Why assign anything? Well, let's see. That's a good question. Um, let's hope there isn't any anarchy happening. Let's go for the good in people and assume that the world's not going to be set on fire as of Wednesday. I'm going to stay in my little bubble and hope that things work out okay, whichever way it goes. But we need to pretend like we're going to have a future. You are all the future. Make sure that you learn your design patterns. So, I don't know. That sounds horrible. Get out and vote. Do your thing. Whoever you vote for is who you want to vote for, but make sure you exercise your right to vote. So, Anyway, let's talk about singletons because that's a lot more fun about talking about the world getting set on fire. Um, so last time we talked about singletons, this was a good solid week ago, so hopefully we all remember what these are. This is probably the simplest design pattern we're going to talk about, right? Where there is only ever a single instance of this class and it's accessible throughout. I did some reading based on our chat that we had and some talking with other people. Singletons, the base requirement is that there's only ever one instance of that singleton. Depending on where you look on the internet, if you have the ability to update it later on, it's kind of debatable. It doesn't strictly break the pattern. So in theory, you could have a globally accessible data set that is basically a project-wide global. Some people hate that. Some people like that idea. But the only real requirement is that the class instance is set in stone and the constructor is basically these two are private here. If you strictly want to update internal variables, that's possible. It doesn't break formality, basically. Just kind of something I wanted to circle back to because I know I don't know if it came across. I was not strictly sure if you could update a singleton or not after it was instantiated. I went back and forth and I did some reading, and the internet seems split on the idea. So, but yeah, that was the singleton class. I gave you some Python stuff, and now we're going to talk about a couple of other patterns. Depending on how far we get today, we may also talk about a third pattern, but let's start off with Facade. This is another kind of interesting pattern where basically you're abstracting things out. And again, all these design patterns are all about abstraction, basically, and representing your project in such a way that you make life easier over time. All right, so here we have this Facade class. And this is a nice little high-level pictorial view, not strictly a formal UML diagram. But here you have a bunch of clients, and these could be automated systems, right? They could be robots or API calls or something like that, or people interacting with the system, doesn't matter. They just need to talk to the system itself. And then in your actual program, you have a bunch of subsystems, right? So these would basically be like classes or, basically anything internal to the program. If we're talking about it in the object-oriented paradigm, these are probably classes. The key difference here is that you have a facade class. Note you don't see clients interacting with each individual subclass, each individual subsystem. They only ever talk to the facade. Right, so what this basically gets you is a unified interface to your system, right? It's your front end that you might consider. You don't have to let the callers, so basically those actors outside, they don't have to worry about the internal mechanisms of your particular program. All they care about is accessing this front-end API. It makes life kind of a lot easier from that perspective. And then you can basically kind of route API calls to whichever subsystem you need it to go to. This is a structural pattern, so basically it is something related to that static nature of your system. Right? It's not creational, it's not behavioral. We're simply outlining, the structure, right? So why is this useful? Well, we might have a ton of subsystems that we have, right? They each provide a particular functionality. And we might have hundreds of these little subclasses, and you don't necessarily want an external entity or a user having to worry about which entity we call. So the facade is basically just, hey, I want to get data, and then the facade would know which subclass needs to pull that data out. So basically you're encapsulating functionality. Now I've got a slide here, but I want to pop ahead a little bit to show you the UML. So this would be one example of a UML implementation for Facade. So this is kind of the same view, just more formalized. So you have your clients out here, you have your Facade, and then you have your subsystems. Basically here, the client just calls facade.operation, right? This could be dot get data, dot set data, dot update user, whatever it's going to be. But the client only ever calls dot operation. Dot operation then basically figures out, well, which subsystem do I call? Right, so here the facade has a create relationship with all these various subsystems, and they're going to be specialized in their subclasses, but the facade would route that basically, if that makes sense. So I've got a more realistic example. So some of these I pulled off the Geeks for Geeks website because they have pretty good pictures and explanations of some of these, and I've got the links in here as well. But here, let's say that we're implementing a washing machine controller, right? So I have to wash, I have to rinse, and I have to spin. And I'm sure you've all done laundry where these things are actually controlled by intelligent devices now, right? There's going to be a lot of sensors on them, there's a lot of moving pieces, and it's all software controlled more or less. So this could actually be a real system. But the client doesn't care. The client just wants to push start, right? So client clicks start washing. The washing machine then has three subclasses here. It's going to have a washing cycle where we start the actual wash. We may have a rinse cycle where we get all the soap off, and then we have a spin cycle where we're going to wick all the water off of all of our clothes, right? That standard wash, rinse, spin washing machine thing that we have. So what washing machine's going to do here is it's going to call wash, it's then going to call rinse, then it's going to call spin. Again, this is a very simplistic abstraction of, you're basically just providing that nice interface to the user. This is something that you may already intuitively be doing in some of your projects or some of your, class assignments or any of your programs you've done before where you have kind of like a central caller at the front end, and then that basically handles all of these other calls. That's effectively a facade. Right, so we do have some consequences here as well. It basically simplifies the system for one, um, which is helpful. Basically, the user doesn't have to worry about all these extra objects. You take all of the burden off the user, put it elsewhere. And again, user can be an API. It can be anything automated. So front end is nicer, back end is trickier. Hopefully you can kind of see the trade-off where we're putting the responsibility here. The other aspect to this, though, too, is that if you make changes to the back end, it doesn't impact the user. So the user still just calls washing machine.wash, and then maybe you add in like a load sensing capability, right? How many clothes are in here? How long do I spin for? How much water do I add in, right? This can all be abstracted away to the back end. So we're simplifying the user's perspective. This is also something where we could actually be convenient for normal users, normal actors, but if you have a more powerful system, you're not necessarily limiting their access. So maybe you have me, the normal user, who just wants to push wash and then go, and then you have somebody else who maybe wants to dial in the heat settings, maybe they want to add a particular amount of soap or, whatever you have to do, where I need direct access to some of these components. And that's fine, right? We're not privating out anything here. So it's effectively just a convenience type of thing. So when do we apply this pattern? You can apply it when you don't need all the functionality, right? So I'm going to just have one general call or multiple general calls that give me whatever interaction I need. Maybe we want to hide the internal system. So again, not necessarily private or protected. It's not a requirement of this pattern, but the user doesn't need to know everything that's happening behind the scenes. Again, power users can, if they want, right? Provide that in your documentation. Here's all of our subsystems. Here's all of our calls. By the way, here's this nice facade pattern for your general, your general public. Maybe we want to extend the system, right? So it's possible that we can add a facade on top of a pre-existing framework, and then our facade will extend it in some way. Right, so maybe you pull down an open source project with a ton of components that you want to use in your projects, but you don't want to have to deal with all those components every time, right? Facade would take care of that. And then last point here, which I've just covered up, maybe you can look at it from a manager perspective or a software engineer's perspective, which is what you all are. It might be easier to write a facade than just to learn the system. I can guarantee that a number of you have probably pulled down frameworks, right? Where you want to, let's say, let's learn to use Unity, let's learn Godot, let's learn phaser.js if you're doing a game for all those ideas, right? There is always a learning curve to getting into those frameworks. Okay, that's fine. But what if you wrote a facade which calls all of the internal components that you need, but it's in a class representation you understand? It's kind of like jumping into Vim in a way, or Emacs, where your facade would be Notepad++ and it hooks into Vim or something like that, right? So basically, you're providing a nice, easy point of entry here. All right, so does the general concept make sense, I hope? Now, I'm kind of curious here. When would it be useful for you? So I've got a Slido here, so please pop your answers in. I'm curious. I've given the washing machine example here, right? I've kind of given you a general picture, but when would this be useful? Need to get my, let's see. No dead air, right? That's a bad thing for radio and TV. Wait for your responses here. Programs or processes always run consecutively. Yeah, that makes sense. You could also consider it where you could actually thread this out too, right? So it could be parallelized, but you always know what processes those are. Kind of a Simpsons wave thing going here. Chill wave, I guess. So based off of fake information. What do you mean? I'm not quite sure what you're getting at there. Also, why did that answer disappear? Slido, you're killing me. It did show up momentarily, right? So it was... consecutively. Right, Scott, that was your other point, I think. I wonder if when I Alt-Tab it, like, refreshes. Because if I do this, and then I come back, did it go away? Oh well. So, based off of fake information, oh, it's not sure if it would work since information needs to be pulled. Well, what do you mean by information needing to be pulled, I suppose? Oh, now it's up. Okay, just a slight delay here. Let me get rid of that. Ours could allow, for instance, it requires for information to be pulled so big. Oh, okay, I see what you're saying here. Well, your facade could basically... You could have multiple facade instances too. So one, like the first part would be getting information. Right. Well, you could have a different level of a facade too, right? So you could have a facade for all of your function calls to do the scraping. You know, you might have different API calls for different websites, and your facade might just call .scrape. Hard code info to be displayed by the GUI. Yeah. Yeah, and like I said, this kind of a thing is something that I'm gonna guess you're all going to do intuitively at some point, right? So let's maybe take it from a game example. Your facade would be game.start. Game.start then has all of your drawing calls, your enemy update calls, all of your user input calls, and basically game.start is effectively your facade in a way. Now, it's not as simple as like what can be as simple depending on your viewpoint, I guess. It's not just like one function calls another bunch of functions. You would ideally have separate classes that are all kind of tied together here to make this a little bit more useful. But the idea is kind of the same thing here. So, good job. All right, so I've got some Java code here again, and I'll do the Python stuff. But here we are simulating a computer. So here we have the complex parts of the facade pattern, and next we actually have the facade part and then the client part. So here we have some classes, and these are your components from the diagrams before. So here's our CPU class, here's our hard drive class, our memory class. What does our CPU do? Well, it can freeze, it can jump to a position, it can execute some code. Our hard drive can read some data, our memory can load something out of RAM. So basically here we have very separate subsystems, right? There's not really any overlap here because they each have their own task. Now, the facade aspect is where you lump everything together. So the CPU, the RAM, and the hard drive, these are all going to be private variables. Would use, yeah, I probably would say that actually. So libraries are kind of effectively facades, right? Because you're just abstracting calls, so you don't want to have to call everything. So yeah, I suppose depending on how the library is structured, you could consider it a facade. That's a good insight, I would say. So here's a facade aspect of the CPU, right? We're again simulating a computer. So we don't want the user to have to worry about instantiating the processor, instantiating the RAM, instantiate the hard drive. All they care about is calling start, right? So we're going to have a public interface, or sorry, a public constructor for creating this thing. Internally, we're going to create all the separate subsystems, right? So we are going to have access to them. And the way this is structured, it's all private. And then once we call start, we're basically going to do whatever we need to do under the hood. This could be sequential, could be in parallel, it doesn't really matter. The point is that the user doesn't care about all this stuff, right? They just care about computer.start. So yeah, your point, Kyle, is actually great. You're basically writing libraries with this kind of a pattern here. But the other thing to consider too with this is that you might be sitting here thinking, yeah, this is useless. Why would I go through all this extra effort? Keep in mind, you're not always the lone developer on a project, right? You might be writing the super complicated CPU, hard drive, memory, or go back to this washing machine example. You might be writing the controllers for each of these separate subsystems. This has, like, you have to access actuators and motors, and you have to open valves to release water, and there's a crap ton of heavy lifting under the hood. But again, you might be doing the tricky stuff, and then you might have another person working on the front end interface or the API call or something like that, right? So if you can kind of abstract things out for other people, you might actually take this as a way to reduce errors as well down the line, right? Because you have all of this effort abstracted away where it's effectively its own atomic unit. So very complicated way of saying make your programs easier for others to use. And if you're doing this in your term projects for any reason, your future selves will thank you for giving yourself an easy way to call some particular bit of code. So yeah, this is effectively some Java code. Obviously, there's a lot of fill in the blanks here, like what does freeze mean, what does jump mean, what does execute mean, what does reading a hard drive mean, right? We don't have the actual code in there for that, and you'd have to simulate it in some way. But you have kind of the framework here. Now we can do this in Python as well, and this is not my most favorite way of laying out code. I'll actually show you the code here momentarily. But here we have similar ideas where we have our washing, rinsing, spinning code, and this is off that Geeks for Geeks website. I've got, oops. Did I already talk about this? Oh, I've got the exact same question here. That's not helpful. Sorry. I was quickly adding class interactions earlier. All right, so here's our washing, rinsing, spinning cycles, right? So these are all of our subsystems. These are our components. They are classes in Python. We don't necessarily need an init. We don't need, we don't necessarily need to create the class, but we have at least the function calls here. Would you want to make the methods within the Facade class methods private because the user doesn't care about them? You can. The pattern description doesn't require it, though. So if we go back here, I assume this is what you're talking about, where these methods are all public and you're asking if they could be private. So if that is your question, consider that you might want somebody to have access to these function calls. So the Facade part is making it easier, right? You have .start, but you might also want particular direct access for some reason. So this is kind of where letting the power users handle some things comes into play. If you want to make them private, you're more than welcome to, right? If you don't want anybody touching this stuff, go ahead and make them private. Shouldn't necessarily break the pattern description. All right, so going back to this washing machine example, we effectively have the same idea here. We have three subclasses, wash, rinse, spin. And then in our Facade class, let's create three instances of that component. Then when we actually run our cycle, just call their respective functions. Nothing super tricky here where you're just calling like one function name and it automatically knows how to do it. Internally, the facade has to know what to do. But the consideration here is basically we're separating out responsibility, right? The main method in this example would be your client. The Facade is responsible for knowing internally what's going on. So I do have some code for this to show you. I'm not going to type it all out because it would take too long probably, and I want to get through some of the stuff. I realized that I should probably start putting all this code up in Blackboard, so if I forget by next class, please remind me. Because it's probably helpful for you to actually have the code itself. So here is basically a transcription of the code from the slides. So here's our washing class. So this is subsystem 1, rinsing is subsystem 2, spinning is subsystem 3. These are our components. If we wanted to get complicated with instantiating variables, how much time is left, what's been done so far, you can add that in. But for this example, we don't care. We just want them to say that they're doing their job. All right, and then here's our facade, right? And we will initialize this thing because we want to set the internal variables to be these components, and then we're going to call their respective functions. Now, could we be cute about this and just have them do this on like a .run function or an instantiation? Sure, but this is a little bit more verbose, and sometimes being verbose helps communicate what your intentions are. But here's our facade, and then again, our main method is your user interface, your client interface, right? This might be the thing you publish in your public documentation. So, yeah, let's do that. This should be a pretty simple, pretty simple bit of code to run. This is facade, washing, rinsing, spinning, right? Pretty straightforward. If I needed to spin and then rinse, I just change the order, and we see the order changed, right? Nothing super tricky from a data hiding or abstraction. Abstraction, but I mean like redirecting function calls or anything like that here. But powerful when used correctly, I would say. So Facade makes sense? Any questions on this guy? Otherwise, I assume we can move on to the observer. Now, this is an interesting one where basically we are getting into our first behavioral pattern. Now, this is going to look similar to Facade, right? We have a central interface here. I liked this figure. I found it on, it was a Medium article on the Observer class. But we still see here like a one-to-many relationship, right? But the key difference here is that we don't necessarily have a user having nice, easy access to all these subclasses. What we're getting at with the observer is that we're basically having a notification relationship. All right, so let's say that we have a subject, this child that we're watching, and then we have a bunch of observers. So maybe the kid is doing something dangerous, and we want to notify every single person in charge of watching the infant in whatever format they want, right? So send a ping on Slack, send an email, send a screen message, send a text message, right? Baby is fallen over, or I don't know. I'm trying to think of something that's not going to make me cringe about the horrible noises I'm hearing from upstairs. But what happens is that with this particular pattern, something happens to an object here, and then any observer that is basically, for lack of a better term, tagged to watch it or basically attached to the subject gets a notification that something has happened. Susisk. Yes, Ceresus. And you speaking in German this semester has made me realize how much vocabulary in German I have lost over the past 10 years. Makes me very sad that I've got to look up so many things these days. If any of you have learned a second language, don't let it lapse. It goes away and it's really hard to come back. But, observer, right. So, something happens here, a notify call goes out, and then anybody observing it will get a notification that something happened. Okay, so one-to-many relationship, and we're looking at a state change. So this by nature is behavioral, right? This is not strictly a structure thing. We are looking at basically an event-driven type of pattern here, where messages are getting passed because something has happened, right? We are observing a behavior happening here. Now, the issue, and again, think of this from like a class perspective, from a UML perspective, where you're going to have a bunch of different classes, right? And they're all going to have different attributes and different methods and different focuses, right? However, they all may need a notification, and there has to be a common way that they all get notified without you, the developer, running like a for loop through a list every time saying, okay, update the parent, update the babysitter, update the grandparent, handling them all separately. You want one nice and easy way to do this. Nice thing in Java is this is actually baked into the language, so we'll look at that momentarily. Effectively, what we're doing with this pattern is that we're doing some delegation. So we're going to create a bunch of observers. We're going to set them to watch a class, and then anytime something happens to that class, the observers will get told that something has happened. So, when do you use this? When something needs to be notified of a change, right? If you, I like going back to the game example because it's wonderful for this. Let's say that you have, I've recently gotten rehooked into Realm of the Mad God, which was a lovely browser game. Now it's a Unity game. But it's basically a massively multiplayer game, bullet hell type of thing. Let's say that you shoot a bullet at a monster. Okay, so an event has happened. Everybody around that user needs to be notified that this bullet is now in existence, right? All of the monster classes in the area need to know because they need to figure out if collision has happened. Maybe other players if it's a PvP type of game where, basically any interaction that has to occur, a notification would go out. That way you're not doing collision detection on the entire world. If you've ever done game programming, you might realize that slows things down. You only check collisions in a particular close area. But basically, something has happened, nearby objects need to be notified. What is a nearby object? Well, that could be where you apply this observer pattern. If I'm within a particular radius, I attach myself to any objects in this area. So we get notified that something's happened. Um, so that's when we would use this, is when a notification has to occur, or maybe we can't necessarily anticipate everything about a particular event that's going to happen. So this is kind of a weird, really weird phrasing. Basically, we know that something will happen. We might not necessarily know what is going to happen, maybe what configuration, what data is coming through. Maybe it's like a JSON packet where we don't know what's inside of it, but we will get notified and then we can handle it internally, right? So here's a look at the UML of this thing. Might notice it's starting to get a little bit more complicated. But if you remember the terms from before, we had a subject, which is basically the thing being watched, and then you have observers. So we will have a subject, we will have any number of observers, and then we'll have this concrete subject and concrete observer class, which we'll talk about momentarily. But basically what you're going to do for the subject is that for every observer that is attached, update if something happens. Right, so you can hopefully kind of see that we're getting a little bit more complicated, right? Observers are being generalized into particular concrete observers. Subjects are getting abstracted, generalized into concrete subjects, where we might check what the state is. If the state has changed, notify observers, this kind of thing. So rather than look at the UML aspect, which you probably should be getting a good appreciation for, I guess, let's actually look at some implementation details here. So how do you do this? First and foremost, have each of your observer classes implement the same interface, so an update call. Right, so your observers need to have a update method. And why do they need that? So that you can just call observer.update. Now you might have different types of observers, and that's where the specialization comes into play here, right? We're generalizing based on what type the observer is. Again, going back to my game example, you might have an enemy class, you might have a player class, environment if it's destructible, whatever, it doesn't matter. They're different, right? Different classes. They may generalize to the same superclass, which again is this hollow triangle here. But the observer has an update function. They all have the same update function. You could call it whatever you want, it doesn't have to be update, but it makes sense if you call it that, right? So when you loop over your observer pattern implementation, you just call observer.update. And again, enemy.update, monster.update, player.update. Doesn't matter, it's going to be the same thing. But they're going to know to watch for messages. Also, make sure your observers know what to watch for, because you might not need every bit of information. Subject state may have changed, but it might not be relevant to your observer. So if you're not having players attack each other, they shouldn't necessarily need to watch out for bullets, perhaps, right? Or collisions with other players. They don't care about that. So if that state pops up, they just ignore it. But you might also have an attach and detach method where basically you're going to attach yourself to receive messages. So if you don't want to think of a game example, another great example is the Internet of Things type of environment where you have a bunch of sensors sending out data. If you've ever heard of the pub sub and the publish subscribe method, basically somebody sends out data, other entities will subscribe to that data and pull it down. It's kind of a similar idea here where you don't necessarily want to pull down all of the information. So depending on how you attach and detach yourself is kind of important. All right, so let's say that our observer has been attached. We are watching for an event to happen. The subject then will notify the observers when the event occurs, right? So a notify function will be called, all of the observers will be updated that are attached, and then you might detach yourself when you're done. You can be attached and detached as many times as you want to be. So what we're doing here is we are keeping things flexible. We are decoupling our entities. If you remember, all of this is about abstracting things out, making life easier, more maintainable. This is another way that we can do that. So, let's see. Did I explain that? Okay, does everybody understand kind of what observer is all about? Basically, instead of directly sending information to many disparate classes, and that basically means they could be different. They could all be the same. Just depends on your implementation, obviously, right? But you're effectively becoming an event-driven program by doing this. Something has happened, then you notify the interested parties of that event happening. Here we start getting into a little bit of the trickery. Now, the interesting thing is that this is actually baked into Java. So in the java.util package, there is an observable and an observer class that's in there, right? So we can add observers, delete them, notify observers, maybe with some arguments. We can set that our state has changed. We can clear the change. We can count how many observers we have. The point is that this pattern is so useful, it's actually in the utilities class. So if you're doing things in Java, you already have access to this without any extra effort. Um, so let's say that we have basically created our class, right? So here's all of your basic methods that you've got for observable. If I want to actually implement it, I could just call update, and then anybody would be updated. So I've got an example here, and we are basically scanning for information. So here we have an event source. It's extending observable. It implements runnable. So your standard kind of Java decorators at the top. While our program's running, we may implement a scanner, and if we have gotten a response, we will set that our observer state has changed, right? So our subject has changed by calling set changed, and then we're going to notify our observers. By importing this observable class, we can basically just directly call this. And then on the other side of things, we would add any number of observers to our particular system to see, hey, has a response come in? So this could effectively be like a chat program or something like that, right? Where you have all of your observers are the people connected to the chat, and anytime something has changed, you just pop that message up. Right, so again, I'm not going to necessarily go into the super deep details of the Java language for this. I'm going to assume that you can all implement this, but it should hopefully make sense, right? So here we have an application. Here we have our observable aspect of things. We are going to add an observer for whatever data is being entered in by the user. So we can kick off a thread that handles this. It's going to wait for input and then notify any observer that something has changed. And again, if you think of doing like a chat application where you're waiting for user input, once you see user input, you blast it out to a socket, and that socket would then be watched by any other client, and then your text would go in there. You're basically offloading all of the heavy lifting to the observers here, or the subject is in charge of notifying the observers that it's happening. So again, effectively a level of abstraction for us here. Now, if we look at this from Python's perspective, it's a little bit less clear what's happening in this example. Basically, we're doing a fake downloader. So it's a threaded downloading system type of thing. So every object here is going to be an observer. When an event happens, it's going to print. So effectively what we have is we have a downloader class, just kind of going to be effectively our subject. We're going to use threading. If you're a Python person, you might cringe at the idea of importing threading, but it works. It's okay. PDB, this is a debugger. It's not actually used in the example. I just copied it verbatim so that there wasn't any difference from the link to what's in here. The link's kind of in gray down there. But here is our downloader, our subject. Basically, we want to download some data. We're going to fake some information happening, and we're going to fake a delay, like we're actually downloading something. And then we're going to do this lovely unfun print, which basically means the function's done. But here's our objects, and these are our observers, where basically we also inherit the thread class, and when we're running, we're going to basically run, going to fake some data, and then we're going to join our threads. And the T that you see here, maybe I should have renamed these a little bit. The T is your downloader, so this is your subject, right? So here is our subject as our downloader. In our observer, we're going to join things up, meaning that we're basically forcing an interaction to happen. Not as pretty as it is in Java, I will admit that, but it gets the idea across. So here we have 3 observers, and we have our subject. All right. So I've got this as well. And again, basically the same code that you've got that I just showed you. And this is going to look like, yep, it's working kind of a thing. We don't really get a whole lot of good information. Basically what we're seeing here is that we have 3 workers running. And again, the workers are the observers. They're getting notified that something's happening. So every time you see a print statement from the workers, basically an event has happened to the subject. Now the observers kick off their own thing, if that makes sense. So again, we don't necessarily have any kind of like data hiding going on in here, right? So if you look at the Java instantiation, everything here is public, more or less. Set changed and clear changed is protected, but your observers have access to them, right? Here, our observer class is public. Everything here is basically public. So we're not like strictly hiding any information under the scenes. We're just attaching ourselves for updates, right? Give me an update, and then I'm going to do something with that information. This idea makes sense? So if it does, how would you add this to your term projects? So again, I'm not going to assume that you're all experts on how to directly implement an observer, but keep in mind the idea is that you have a something, right? It doesn't matter what it is. It's going to undergo a state change. Could be a form element, it could be a character in a game, it could be a bank account, I mean, a calendar entry, it could be anything, as long as it is an object. And you know that it's going to change state. Well, if you have something changing state, you might need other things watching it. And what are those things going to do? Are they all the same? Are they different? You know, if you have like a bank account and you see a massive transaction happen, you might have, okay, well, I'm going to notify the GUI. I'm going to have a user, like I'm going to send an automated text saying, hey, you lost $2,000 out of your account. Did you mean for that to happen? I'm going to send a phone call. I'm going to send an email. So how might you use this in your projects? And just like that, we're at the end of class and I'm out of coffee. This is perfect timing. Any guesses here? And I guess if you don't see your answer on slide, you pop it into the chat if you are actively paying attention, I suppose. I'm starting to wonder now if there's a disconnect between Slido and reality, I suppose. Just want to see if this is working because with some of you losing your messages here, come on, there we go. All right, well, I guess if not, technically that's the end of class, so I will see you all on Wednesday. Any remaining questions before I sign off and pop over to office hours? Okay, it's working for me at least, so I'm guessing people have drifted off or might not get observer. All right, well, other than that, I hope you have a wonderful day. I will see you Wednesday and enjoy the heat wave, which is apparently coming. So, bye, everybody. Have a great day.